Welcome to this current affair topic, earthquake swarms. Recently in the news, California earthquake is on current affair. It has been observed more than hundreds of earthquake is coming in the California, and it is ranging from 2.5 to 4.9 magnitude. So that's why this swarms kind of earthquake is in use. So how this earthquake swarms is different from the normal earthquake? What are the consequences of it? Whether do we have to worry about it or not, we will see in this lecture. Moving ahead, in this slide we can see there is two graphs. The first graph is denoting you the normal earthquake, and the second graph is denoting you the swarm earthquake. In the normal earthquake, we will see before coming of the main shock, we will see there is a something called as foreshocks, and then after we will receive main shock, and then after the main shock we will receive aftershocks. This after primary shock, that foreshock is comes in the way of primary waves, P waves. Then there will have a main shock that sometimes we call as a surface wave also. It may denote as a surface wave too, because this is surface wave becomes one of the main reason for the destruction of life and property during the earthquake. Then we will see aftershocks. Aftershocks is observed due to the balancing of the disturbance occurred due to the earthquake beneath the earth, or if there is something plates movement or the rocks movement beneath the earthquake due to the earthquake and all, then they will try to settle it, they will try to balance it all. So that's why we will observe aftershocks. So what is earthquake swarms and what is main shock? First we will go through this slide. See, whenever earth shakes due to the rearrangement of the rocks, swarms that this line mainly denotes that earthquake happens due to the rearrangement of rocks only. Then swarms also happen due to the rearrangement of the rocks. But the difference between the normal earthquake and the swarms earthquake is that in this swarms earthquake, all the shakings of the earth are lying on the same magnitude. Like these in the California, it is between the 2.5 to 4.9. So similarly, all the earthquake is what is coming is ranging from 2.5 to 4.9. Like sometimes it may be 4.9, 4.5, then 3, then 2, then again 4.9. So the data that we are observing is a kind of homogeneous reading of the data is taking place. But in the normal earthquake, we can see that foreshocks, main shocks and aftershocks. Now the point to note here that this earthquake swarm is not much dangerous than the normal earthquake, because there is no surface wave kind of situation that may topple your buildings and all. That kind of situation we are not observing here. And further, to topple the buildings and all, we need higher magnitude kind of earthquake. Like if it is greater than 5.5, 6, then we can observe the destruction of life and property. Even in the surface wave, we have two different types of wave, like Rayleigh waves and love waves. These things we will discuss in geography lecture as a separate for earthquake. Here I am giving an overview of it with the current affair topic. Okay, so in the normal earthquake, before main quake shaking happens, that is foreshocks, and after main earthquake we will see another shakings happen, that is aftershocks. And in earthquake swarms, foreshocks and aftershocks are lying on the same line. All these foreshocks, aftershocks, main shocks, we are unable to identify which dot is denoting the foreshock, which dot is denoting the aftershock. Yes, we can observe, we can tell that these lower magnitudes are foreshock, these smaller magnitude are aftershock, and this top one is your main shock. But it is difficult to differentiate. Then also it is very difficult to differentiate. Okay, because we can see that this dot and this dot has lots of difference. Like the aftershock is here, then again aftershock we can see this shock, and if we denote this dot as a main shock, then there is not much difference between those magnitude. Okay, so that's why we say that in the earthquake swarms, foreshocks and aftershocks lies on the same line, and it is little bit difficult to differentiate which one is aftershock, which one is foreshock by looking on the graph. But in the normal earthquake, we can see foreshock, main shock and aftershock, and we can clearly differentiate between those shocks. That's why there is a difference in earthquake swarms and the main shock. Now we have to understand how do they develop. How do these earthquake swarms develop? Earthquake develops, we know, like the reason is only the plate tectonics movement and all. Either the earthquakes can occur because of converging of two boundary, diverging of two boundary, or transient kind of things like rubbing of two boundaries and all. These three are common things, but what is the reason behind earthquake swarms? Okay, we will see in this slide. See, if this is your earth, if this is your soil, land region, then we have lots of rocks and we have water pools also beneath that earth also. Okay, so when, let us suppose, when rainwater accumulates in a particular area, then what will happen? This area will become a pool of water. Okay, and ultimately there will be a disbalance kind of situation in that area beneath the land, deep inside the land. Now what will happen? This rock structure will try to balance it. Like if water have penetrated too much, water is the another reason. There may be another reason of rock development kind of things. If have rocks, if they have some formation of new rocks and all, then that can also lead to a formation of disbalancing. Okay, now this collection of water is one of the reason of causing earthquake swarms. I'm not saying this is the only reason, it is one of the reason. Okay, so now the rock will try to balance it. Now this cause a situation of regular earthquake. It will be a more than a 1 month, 2 months, or continuously even it will continue for years. Okay, because see, your earth, soil beneath the earth, it is not like a open structure, it is not a open space kind of things. So whatever things will happen, it will happen slowly. It needs energy to do it, and ultimately and unless whenever the energy accumulates, then only you can see some kind of development within the earth and the displacement of these rocks, or the penetration of deep penetration of water and the balancing of all those kind of things. Okay, so this is one of the reason of formation of swarms. Okay, so in this slide they can develop, that swarms, earthquake swarms can develop due to disturbance in the inner rock structure. Deformation in the upper layer will try to rebalance themselves and leads to movement of the ground surface. That thing I have explained. I've explained in the form of accumulation of water. Even if, let us suppose, there have been some disbalancing in the upper layer only because of human interference, then also if the disbalance occurred, then the rock structure will try to balance it, and it may cause quakes, earthquake kind of situation. So thus this will leads to quakes. And rebalancing may also due to excessive water penetration. This was first discovered in India in Maharashtra 2019, and still we can see earthquake happening in that region because of that only. Even if rainwater accumulates, we can see for some duration in a month also earthquake is continuously there, but the magnitude is very low. So due to excessive amount of rainfall and rainwater tends to seep through the cracks in the rock layers, and it caused earthquake swarms. Okay, so sometimes they do penetrate or in depth areas, and when they go for depth areas, they will form a pool kind of situation that I explained it here, and leads to disbalance in the rock structure, and ultimately when they try to balance it, then it will cause a earthquake. So in case of normal earthquake, the normal earthquake is stronger in magnitude and it leads to large scale devastation, whereas note it, whereas earthquake swarms are minor shakes, and this may even kind of warning a main earthquake is going to hit in coming days. Why this statement is written? This statement denotes that it is an warning, that it is giving that there is something disbalancing beneath the earth. Let us suppose when this pool of water, like let us suppose a pool of water is created. Okay, this is a pool of water is created. Now the rock structure will try to balance it. Okay, now when it try to balance it, you will see a earthquake swarms kind of situation and less hitting of earth soil, that less destruction and all. And after some time, when they try to balance it, it may cause more disbalance in the soil, like it may cause more destruction, more destruction, like a structural error beneath the soil, and it will ultimately lead to a greater or normal earthquake, and it may also lead to a plate disturbance, tectonic plate disturbance. That's why it is telling that this give a kind of warning, a main earthquake is coming and hitting in coming days. So this may be treated as a warning for a main earthquake is coming. Just note one point here that I have mentioned also, and I will explain it in much detail, that the only way to detect the earthquake is if we collect the information of P waves earlier, then only we can detect earthquake and we can save the livelihood. Now the question may come, what is P waves and all? I will explain it in the separate lecture, in the geography lecture, but I will give just a small introduction kind of things. Like see, this is your primary wave, like contraction and compaction. Like see, this is your compaction, this is the contraction, this is your compaction. Just see, this is a sound wave kind of thing. The example of P wave is sound wave. So the first wave that we denote, that we collect, is P waves in the earthquake. Then only we can detect the coming earthquake. Okay, so this P waves particularly vibrate along the direction of the propagation of the wave, and it is parallel to the wave. So the particle movement happens between this one. So high frequency, the shorter wavelength, and the travel through both solid and liquid. The main thing to collect is that we will study in the earthquake lecture that we have a mantle, crust and core. Okay, when earthquake happens, P waves travel from core also, and it travels from that crust also, mantle also. So mantle is little bit solid, then crust is also solid, core is a liquid. So we will observe that P waves is also going through the core part, and we are receiving this P waves in the opposite direction of the earth. And in the secondary wave, there is two types of primary wave and secondary wave. P waves is nothing but primary waves, and we will have a secondary wave that does not travel in liquid. So when the secondary waves come, we will see that secondary wave hit your mantle, it will hit your crust, but we won't absorb secondary wave in your core part, because core part is in liquid form, and ultimately your secondary wave lost in the core. So these things we will discuss separately in the earthquake in the geography lecture. I have just given you an introduction that why P waves is important to detect the earthquake. P waves is the first one wave that is collected, and it travels through the liquid also, and the speed is around 4 to 7 km per second in crust, and 8 to 8.5 km per second it is in mantle. So it is 8 to 8.5 in the into this one, and in the crust you will send 4 to 7 kilometer per second. And the example of this, that the primary wave is your sound wave, and the secondary wave is just like, it is your like a wave ripples, light waves, that is will call your secondary waves. Okay, so the P waves will be your longitudinal waves or the compressional wave, and the secondary wave will be forms like water ripples and all. In the secondary waves we have a speed of 2.4 kilometer per second in the crust and 4.5 in the mantle, and it also have a high frequency and short wavelength, and the particles moves in this one, like in this one the particle moves in the perpendicular direction. Okay, so when this waves comes, then particle move will above. So in this kind secondary waves, particle moves in that is in perpendicular direction. So these things we will discuss more in detail in the separate lecture for the earthquake. So I hope you have understand all those things. Now this the last topic, that is the earthquake swarm in India. As I already explained, that in 2018 an earthquake swarm was detected first in India only in Maharashtra, Dhanau region. Even if you Google it, you will see the recent earthquake, and still we receive earthquake on those regions. It is nothing but it is earthquake swarms, that is a disbalance of when the rainwater accumulates or something like that, like water accumulation and all, then balancing occur, and it leads to earthquake swarms kind of situation in Dhanau region of Maharashtra. So 10 to 20 earthquakes are felt daily with magnitude usually smaller than 3.5, and maximum magnitude is 4.1 in February 2019. So you have to remember, just remember it place, that it is in Maharashtra and the place name is Dhanau. Okay, you can remember this Dhanau name as a Dhanush, so you can just keep it. These questions will come in the MCQ type of questions. Okay, so I hope you have understand everything. Please like and subscribe. Your subscription is a form of payment for me. If you have any on-demand video lecture, if you want give me suggestions or feedback, please feel free to ping on my Twitter handle. Thank you.